and we'll do that. So here we're missing Javier and Pedro, of course. All right.
Yeah.
All right. So what I would like to do is I want to start off with doing our spheres. Now our spheres we're doing in the book because for them, all the spheres are basically the same. You can't have different shape bases or anything. They don't have different faces, different sides, because it's all one surface, okay? A sphere is a three-dimensional circle, so there's all one surface. So since we don't have different faces or anything, you don't have bases to worry about like we did having different shape bases with our prisms or our pyramids. It's a lot easier, okay? You don't have two different areas because like I said, there's only the one surface. So we have our surface area formula, which basically is the area of a circle times 4, okay? So it's 4 pi r squared. And then we have our volume formula, which is 4/3 pi r cubed. Because remember, area is in square units and volume is in cubic units. So those are the two formulas that we're using. Now you'll notice I did put this up here, and this is something that I put on the quiz for the problem I think you had for the cylinder too, and we'll talk about that more later. Because in the picture, they gave you the diameter, but what we need for our formulas is the radius. So you have to remember that the radius is equal to half of the diameter. Okay, so we have some problems where we're going to have to use that in here as well. Now, if you look in your book, the problems are on page 438 and 439. Now notice we're not doing that many. It's about the same number of problems that we did when we did our cones and our prisms and our stuff on the worksheets. We're doing 1 through 11 and then 30 and 31. Okay, now for the first 3 problems, they actually give you the picture of the sphere. Okay, now this sphere, they have what they call a great circle, great circles of the sphere. You kind of think about it as a globe. The great circle that goes around the center of our globe is called our equator. Okay, y'all have heard of the equator before? Okay, so it's a great circle. It's a circle that goes around the entire figure. Okay, so we have our great circle that goes around in our sphere here, and then halfway across that great circle, just like on our regular circles, are the radius. Okay, so that is what we're using for our 2 formulas. We're talking about the surface area, what it would take to cover the outside of the sphere, and then our volume, what it would take to fill up the sphere. Okay, so everybody's with me on page 438? Good. Some of you, you're not in your screen anymore. Okay, Kernaya's giving me a thumbs up. She's got it. Maya, I just see the bed. Kaya and Monica, yours is dark where it's hard to see you. Okay, now for these, we have to pay attention to what the question is actually asking us for, because they're going to switch back and forth. Sometimes they're going to say, find the surface area. Sometimes they're going to say for the volume. Sometimes they may say, what can I do, or how much would it take to fill up something? If I'm talking about filling it up, remember, that's the volume. If I'm talking about painting the outside of the ball or whatever it is, then that's the surface area that's covering the outside. So you've got to kind of read sometimes with our word problems, you got to think a little bit more. But on 1, 2, and 3, they just give you the picture of the sphere. They actually have the sphere there in the book. So you're looking for which thing it's asking you in the directions to find, and then you make sure you use your right formula. Okay, so for number 1, if you look, it gives you the radius is 4 inches, and it's asking us to find the surface area. Now remember, for our problems that we did with the cylinders and the cones, did we actually plug in a number for pi? Did we plug in a number for pi?
No.
Okay, we didn't plug in a number for pi. We use the pi symbol. We kind of leave it in there like a variable on the end of the problem. Okay, so on number 1, it's wanting the surface area, and it has a radius of 4. So I'm using my surface area formula, and it's equal to 4 times pi times my radius squared. And the radius that it gave us in the picture was 4 inches. So we just work this out. 4 squared is 16. 16 times 4 is 64 pi. And then again, it was area. So area is measured in square units, so it's inches squared. And that's your answer, that's it. Okay? I told you, for these, they're a little bit easier because it's straight. You have the set formula. You don't have to worry about whether the base was a triangle or a rectangle or whatever it was. You have the set formula. It's all the same. Okay? Now, number 2 is the same way. You'll notice I didn't put number 2 up here because I'm going to have you all try that one in a minute to see if you all can figure it out right or not. Okay? So I'm going to do number 3. Reason I chose to go ahead and do number 3 with you instead of leaving that one for you to try on the own is because it has that radical in there, and sometimes it's a little bit harder to do the problems that already have a radical in there. So it gives us a radius of square root of 5 feet. So I have surface area is equal 4 times pi times square root of 5 squared. Because you take your radius and you square it. Now, if you remember some basic algebra facts, squaring something and square rooting something are inverse operations of each other. They're inverse or opposite operations, which means they cancel each other out. Just like adding 5 and subtracting 5 cancel each other out because they're inverse operations. So that part cancels. You're canceled out, you're left with just 5. If you think about it, you could multiply it if you wanted to. Square root of 5 times square root of 5 would be square root of 25, which still just equals the 5. So the easiest way to do it is just know that those cancel each other out and you got 5 by itself. So then I got 4 times pi times 5. So I have 20 pi, and I believe it was feet. So it's feet squared on my answer. Okay? So we did number 1, we did number 3. Think they're pretty easy? Okay, Javier, we're on page 438. We've already done number 1 and number 3, finding the surface area of the sphere with our formula here for surface area of a sphere. And like I said, we've done 1 and 3, so I want everybody to be trying number 2. So everybody do number 2 on their own, please. Okay. And it shouldn't take that long because you just plug into the little formula, work it out. I'm already done. I didn't even have to write down. And I wasn't looking at the answer first. I did it in my head first and then looked at the answer. So. Okay, who has an answer? Don't say it yet, just like put your hand, I can see that you have an answer. Okay, I'm not seeing many. Because you take the radius, which was 10. 10 squared is 100. 100 times the 4 pi is going to be 400 pi
Centimeter squared.
centimeters squared. Okay, so these are pretty easy, right?
Yes, ma'am.
All right. So I said this should be fairly simple for you. Now, number 4 and number 5 are working backwards. Okay? Number 4 and number 5 are working backwards. They're going to give you the surface area, and they're asking for either the radius or the diameter of the sphere. So we have to work backwards. You're still using your surface area formula. Okay? It just takes a little bit more math work to work backwards to get the radius by itself. So for number 4, it wants the diameter of the sphere whose surface area is 676 pi feet squared. So surface area is 676 pi square feet, okay? That's what they gave us. They want to know the diameter, but to find the diameter, I have to find the radius first. I'm still going to use my surface area formula here. So I know that 4 pi r squared is equal to the 676 pi. Okay, now I leave my units off just so they don't complicate stuff and get in the way during the problem, and then I put them back on my final answer. And I'm going to scoot you all a little bit closer. I just had you back further because of the glare earlier. Okay, so you just replace the surface area with what that formula is. Now, your goal in an equation is to get the variable, what's missing, by itself, which in this case is our radius. So to get the r part by itself, these things right now are all multiplied together. So we do the inverse or opposite of multiplication, which is division. So you divide by 4 pi on each side. So when I do that over here, cancels, cancels, I have r squared. When I do that here, the pi cancels, and then 676 divided by 4 is going to be 169. Now, we still don't have r by itself because this isn't r, this is r squared. Remember what I talked about up here on number 3. The opposite of squaring something is the
square root of it.
Square root of it, okay? So since the opposite of squaring is square root, that's what we're going to do on both sides. So we square root both sides, and so I get r is 13. Now that is my radius, but in the problem, they didn't ask about the radius. They asked about the what?
Diameter.
Diameter. Okay,
Yep.
they asked about the diameter. So what I've got to do is I've got to still multiply that by 2. Because remember, the radius goes halfway. I'm going to scoot it back up for a minute. Radius goes halfway across the circle, or the sphere in this case. Diameter goes all the way across. So I have to take my radius answer down here and multiply it by 2. So my diameter will be 26, and then was it feet? Yes. So my diameter will be 26 feet long. Okay. So you're doing the same concept, but we're using our same formula, except when you have to work backwards to find just one of the measurements, it's a little bit more work. Okay. Pedro, we're on page 438. We have done number 1, 3, and 4 together, and everybody's already done number 2 on their own. So now we're starting on number 5. Okay, and some of you, I still can't really see you or your body in your screen at all. Just remember, if I keep telling you that and I can't see you, then you just know you're losing points every day if I can't see you. All right, number 5. Number 5 says find the radius of a sphere whose surface area is 300, I lost my, all right, 320 pi yards squared. So this time we're doing yards instead of feet. Okay, so it gave us our surface area formula. So the opposite, we're doing the same thing. We're going backwards to find the radius this time. So we don't have to do the extra multiplying by 2 at the end, which is good. It's one less step. We're still using our surface area formula up here. Our surface area formula, it's there in your book, plus I had it up here, was 4 times pi times the radius squared. So we know that that is equal to 320 pi for this sphere. And then we got to work backwards because our goal is to find the radius. So I have to get the r squared by itself. Things right next to each other is multiplication. The opposite of multiplication, we divide. So we're dividing both sides by 4 pi. Because when we do that over here, 4's cancel, pi's cancel. Because anything divided by itself is 1. So you got 1 r squared or just r squared. Because 1 times anything is itself. Over on this side, pi's cancel out. 320 divided by 4 is going to be 80. Okay, because 4 goes into 32 8 times, and then you just stick the 0 on the end. Now, we're still not done because this is r squared. I want my r, my radius. So I take square root of both sides. Now, square root of 80, 80 is not a perfect square. Over here, we had 169, which was a perfect square. 80 is not. But I got to do my factors. I can do my factors for 80. I know 80 is 8 times 10. 8 is 2 times 4, which is 2 times 2. And 10 is 2 times 5. Because I'm doing square root. I can look for pairs of common factors that can go outside because it's a square root. Square root means 2. It has to have pairs, 2 at a time. So I have a 2 here and a 2 here that can go outside. 2 times 2 is 4, and then there's a 5 left over. Or you can just cheat and type it in on your calculator, and it'll tell you 4 square root of 5. And then you got to make sure you put your units on your answer. It was measured in yards. So it's 4 square root of 5 yards is the radius for that sphere. Okay? So that's our surface area formula. Kind of getting it down? Yes, no? Okay. Now, starting on the next part, we're starting to talk about volume. Okay, so our volume formula has a fraction in it. Our volume formula is 4/3 pi r cubed. So remember, our cylinder was just pi r squared times the height. Our cone was 1/3 pi r squared times the height because where it shrunk in. And then in this one, it's 4/3 times pi r cubed because the radius, it doesn't have a separate height, it's just the radius in all directions because where it's the round sphere. Now, you'll notice again, I skipped number 6. I'm going to have you all try number 6 on your own after we do 7, 8, and 9. Okay? I tried to pick the easier ones for you to try on your own that don't have like the weird decimals or radicals in them. Okay? Because I know some of y'all struggle. So I'm trying to make it easier on you, but I still want to make sure you at least are getting the formula down right. So, on number 7, make sure you're looking at number 7, not number 6. It says a sphere with a radius of 1/4 meter. Okay, so we're plugging it into our volume formula. Volume, 4/3 times pi times the radius, which it said was 1/4. Right? Yep. 1/4 cubed. Now, when you cube a fraction or square a fraction, you cube or square the top part, the numerator, and you cube or square the bottom part, the denominator. Okay? because it basically means it's multiplying it by itself over and over again. So 1/4 times 1/4 times 1/4. So when I go to do this, 1 times 1 times 1 is 1 on the top. And on the bottom, 4 times 4 times 4. So 4 times 4 is 16 times 4 is 64. So 1/4 cubed is 1/64. Now, what I do instead of always relying on the calculator is I look and see if there's something I can cancel out, cross cancel with my fractions. Okay? 4 goes into itself one time, it's on the top. 4 goes into 64 on the bottom 16 times. So I was able to reduce my fraction by cross canceling. Because you do that when you multiply. Multiply straight across. 1 times 1 on the top is 1. On the bottom, 3 times 16 is 48. I have a pi. And then it was meters, I believe. So it's meters cubed. It is cubed units for volume. Okay, area, square units, volume, cubed units. So that was number 7. Okay. Number 8, still same formula. Okay, number 8, same formula. Says a sphere with a diameter of 8 square root of 3 inches. Uh-oh, they gave us the diameter again. So what do I have to do? Okay, this is like what you had to do on your cylinder on the quiz, but most of you that turned in your quiz already didn't do it. Remember, radius is half of the diameter. Okay, so if my diameter is 8 square root of 3, I have to divide that by 2 to get my radius. So when I divide that by 2, 2 goes into 8 how many times?
4.
So I have 4 square root of 3 is equal to my radius. You have to find your radius first before you can do the formula, because the formula uses the radius. So now I'm ready to plug it in. Volume is 4/3 pi times 4 square root of 3 cubed. 4 square root of 3 cubed. Okay, so this is what we have right now. Now, you can either type 4 square root of 3 in parentheses. Notice I wrote it in parentheses. Anytime I have a radical sign with my number and I'm plugging it into a formula, because I've got to raise it to a power, always put parentheses around there. Because if you're trying to type it in the calculator without those parentheses, it's not going to raise the whole thing to the power. It's only going to raise the last number to the power. Okay? So, Pedro, there's no point in signing in if we're not going to see you. So, I'm going to put parentheses 4 square root of 3, close parentheses. Whoops. Okay. 4 square root of 3, close parentheses, to the 3rd power. So that's how it needs to look if you're trying to type it in on a calculator. Okay. I hit equal, and I get a big long decimal. Okay. So I can take that big long decimal times the fraction 4/3, and I still get a big long decimal. Okay. Now, another way that you can do it is think of, you cube each part, like up here where I cubed both the numerator and then I cubed the denominator, I can do the same here. And so that's what I'm going to do. I'm going to do 4 square root of 3 times 4 square root of 3 times 4 square root of 3. Because I don't want to do the big decimal part. I'm going to leave it in the simpler radical form. Okay? So when I take 4 times 4 times 4, 4 times 4 is 16, 16 times 4 is 64. Okay, we got that part. When I take square root of 3 times square root of 3, I get square root of 9, which is just what? Square root of 9 is 3.
3.
And I have the other square root of 3. So I have 64 times 3 square root of 3. So 64 times 3 is 192. So this whole thing equals 192 square root of 3. I'm doing it like that because I don't want the big long decimal. I want to leave it in its radical form. Okay? So now I'm taking 192 divided by 3 to see if I can cross cancel. 3 goes into it once. 3 is 192.64. I multiply 4 times pi times 64 square root of 3. So 4 times 64 is 256 square root of 3 pi. And then it was in inches. So it's inches cubed. Now, if you had done it out with the decimal, you end up with like 1,390 something as a decimal. But I rather leave it in its radical form. So all of that's for number 8. Okay. This part down here is just my work for how I did up there. That's just where I worked that out. Okay. Everybody good? That one was a little bit longer. That's what I'm saying. I'm doing the more complicated ones. So then when I go back and tell you to do number 6, you'll be like, oh, this one's easy. Okay. Pedro, last warning, if you don't get yourself on the camera, I'm kicking you out. You will not log back in. All right. Number 9. A sphere whose great circle has a circumference of 32 pi centimeters. Okay. So remember I told you the great circle is like the circle around the sphere. So on our picture over here, this is a great circle. Okay. Remember, circumference is just the distance around the circle. Remember, circumference is found by the formula 2 times pi times the radius. Okay, that's our formula for circumference. That's something that we did a couple of chapters ago when we first were talking about circle stuff. Okay, so when we're doing that, it told us our circumference of our great circle was 32 pi. So I have 32 pi is equal to 2 pi r. So it's similar to kind of what we had to do on 4 and 5. We're working backwards a little bit to find our radius. And then after we know our radius, we can plug it into our volume formula. So I'm going to divide both sides by 2 pi because my goal is to find my radius to get it by itself. So when I do that, those go poof, and I have my radius equals, the pi's go poof, 32 divided by 2 is 16. So the radius that I'm going to plug into my volume formula is 16. Now my volume formula was 4/3 times pi times the radius cubed. So I have 16 cubed which is a big number. Okay, 16 times 16 times 16, 4,096. Now, we can try to see if 3 will go into that to cross cancel. It won't. So I'm just going to multiply 4/3. So if you got a calculator, you can put in your little 4/3 fraction times 4,096. And you get an even bigger fraction. So I have 16,384 over 3 pi, and then it was in inches, no, centimeters. So it's centimeters cubed. because we were doing volume, it was in cubic centimeters. Okay. So that is number 9. So number 6, like I said, is easier. Number 6 is a sphere with a radius of 18 feet. So if you plug in the 18, okay, if you plug in the 18, you have volume equals 4/3 times pi times 18 cubed. So I want you to get your answer for number 6. Then we'll check and make sure everybody got that right. So everybody's doing number what? Number 6.
6.
6. You have a big number. Everybody getting that one done? All right, what'd y'all get for number 6? Because you should have had 4/3 times pi times 18 cubed. So you get a big number.
Is it 7776?
Yeah. 7,776 pi
Square.
Feet cubed.
Yep. So that's number 6 right there.
That was easy.
Yep. I tried to leave you an easier one. All right. So now number 10, if you'll notice, I put both the circumference formula and my volume formula here. So it's similar to number 11. It gives us the circumference. So before we can find the volume, we have to work backwards and find our radius. Okay. So if you look at number 10, it says a volleyball. A volleyball is a sphere. Okay. With a circumference of 26 inches. So I plug in 26 inches here for my circumference, and that's equal to 2 pi r. Now the only thing is on this one, it didn't have the pi over here. So we're still gonna have a pi in our radius. We have to divide this by 2 pi. We have to divide this by 2 pi. So I get my radius by itself. Here, 2 goes into the 26 13 times, but then I still have that pi in the denominator, okay? Because I didn't have 1 for it to cancel out with. So that just makes it a little bit funky looking when we go to plug it in, okay? So now we're ready to plug it in. 4/3 times pi times our radius, 13 over pi cubed. Now remember what I talked about with cubed. That means you're multiplying it by itself 3 times. So that means I'm going to have 13 times 13 times 13, right? 13 times 13 times 13 in the top. Which is 2,197. And then pi times pi times pi is pi cubed. So that's what I have right now. Okay. Now, I can't cancel anything out because 13 is a prime number. So just I multiplied 13 times 13 times 13. Still, the only factor that goes into it is 13. So there, I can't do the 3 into that. It's not going to go evenly. It's not going to work. Okay. I can. I have a pi here and 3 pi's down here, so I can cancel one of those pi's out. So that cancels, and I'm left with 2 pi's in the bottom. And then we're ready to multiply straight across. So I have 4 times the 2197. So I have 8788 in the top. And then on the bottom, I will have 3 pi squared. And then I forgot what the units are. Inches. That's what I was trying to find. Inches cubed. So that would be the volume of that volleyball. Okay. Oh, I need to sneeze. Excuse me. Sorry. All right. I knew it was coming. All right, number 11. Number 11 says, how many cubic feet of gas are needed to fill a spherical weather balloon with a radius of 15 feet? Okay, so it's a sphere, and it gave us the radius. It's talking about cubic units to fill it. So am I finding the area or the volume?
Volume.
Volume.
This is talking about cubic units. So my volume is 4/3 times pi times the radius, which was 15 cubed. So this one should be pretty easy. Remember, you can put anything as a fraction over 1 if you want. You can try to cross cancel. I know 3 does go into that one because 3 goes into 15. Multiply that times the 4. So my volume is, and I think it was feet. So it's feet cubed. Pretty easy. Okay. We won't worry about 30 and 31 right now. We'll talk about them later because I want to be able to go over some stuff from your quiz with you so y'all can get your quiz finished up. So we'll talk about that for these last few minutes. Now on the quiz, for number 1, if you remember yesterday at the end of class, I put over there an octahedron, and we had already counted the vertices, the edges, and the faces. So you had the numbers that you needed to plug in on number 1 into Euler's formula. You've got Euler's formula on your chapter 9 notes and in your book in section 9.1. So everybody should get number 1 right, because all you had to do was take the numbers that we had talked about. We had said there were 6 vertices or corners. You had the vertex at the very top, vertex at the very bottom, and then the 4 that went around the middle were the 2, an octahedron's like 2 pyramids on top of each other. Okay, so we had 6 vertices. Then we had 12 edges, because you had the 4 edges going up and down on the top half of the octahedron. You had the 4 edges going up and down on the bottom half of the octahedron, and then you had the 4 that went around where the 2 halves met. So you got 12. And then faces is the actual sides of the figure. There's 4 triangles that were on the top part and 4 on the bottom, so it was 8. So your numbers that you had to plug in, you had 6 vertices, 12 edges, and 8 faces. You plug them into the formula. The formula is on your notes or in section 9.1 in your book. Now, number 2, the first part on number 2 says, identify the solid formed by the given net. So you tell what shape that's going to be. So if you look, it's made up of 3 rectangles and 2 triangles. So is it going to be a prism or a pyramid?
Prism.
A prism, because a prism has 2 bases, a pyramid just has 1 base. So it's going to be a prism, and then it's the type of prism based on the shape of the base, which that's the 2 sides that are on the top and the bottom of the picture. So you name it in the first long blank. The next 3 things are found on your lateral area, your surface area, and your volume. To find the lateral area of a prism like that, I had on the board yesterday, plus you have it on your worksheet. To find the lateral area, it's the perimeter of the base times the height. So the perimeter of the base means you add the sides of the base together. So what shape in this picture is the base? Whether the triangles or the rectangle?
Rectangles? The triangles?
The triangles are your base, okay? The rectangles are the lateral sides that connect it together. The triangles are the bases. So you add the sides of the triangle and multiply it by the height. The height would be the distance between the 2 triangles. The height is the distance that connects the 2 triangles together. So that's your formula for lateral area. Lateral area is perimeter base times the height, okay? The perimeter in this was a triangle. The base was the triangle, and the height is the length between, and I'll scoot the camera over in a minute, the 2 triangles. And that's not a very pretty triangle, but even. Okay? So that's for number 2, okay? Now, for surface area, remember surface area is just your lateral area plus the area of the bases. Now, we already said the bases were what shape?
Triangle.
Triangles. So to find the surface area, I'll have lateral area plus 2 times the area of the base, which we already said was a triangle. So hopefully you know the formula for a triangle is 1/2 its base times its height, okay? And then for your volume is the area of the base. Oh, look, you already had to do that there. The volume is the area of the base times the height, okay? And we already talked about, when I say height, the height is the length between the 2 triangles, okay? So I'm not talking about the height of the actual little triangle right here. I'm talking about the distance between the 2 triangles in that net, the big picture, okay? Now, for number 3, it is a rectangular prism. So for that, remember your formula is the perimeter of the base times the height for your lateral area. But how do you find the perimeter of a rectangle? How do you find the perimeter of a rectangle?
Multiply.
Yeah, kind of. Okay, it's perimeter of the base, but in this case, it's a rectangle. So the perimeter of a rectangle is 2 times the length plus 2 times the width. Okay, so it's the perimeter of the base times the height, which the height is the one going up and down. Your base is the little rectangle down at the bottom of the picture is your base, the one it's sitting on, and then the height's the one standing up and down. Okay, surface area is still the lateral area plus 2 times the area of the base. Area of a base, the base is a what?
Triangle.
Base is a triangle, right?
Rectangle.
A
Oh,
rectangle.
yeah.
What are you talking about, Javier?
I see a perimeter base is a rectangle.
The area of the base, which in this case is a rectangle. So how do I find the area of a rectangle? Length times width. And then my volume is the area of the base times the height. So it's just going to be length times width times height. Okay?
Okay.
Number 4, on the back, it's a cylinder. Cylinder, you had set formulas. You have those set formulas on your worksheet. I'm not putting them up here again. The reason most of you are missing number 4 is because if you look at your picture, what measurements did they give you?
I don't even know. I have to print it out.
If you look at the top, that 24 feet is the
Diameter.
It is not the radius. On your formulas, it needs the radius. A lot of you who already turned it into me, you plugged in 24 for the R, and so you got these ridiculously large numbers. Okay? That's no. The radius is half of the diameter. So half of 24 is going to be 12 feet. And then you've got your formulas on your worksheets to use for that. Okay. Number 5, you should be pretty good with. Only pointer I want to tell you for number 5 is you got to use R squared plus H squared equals the slant height squared to find your slant height. Your radius is 6, the height is 15, and you got to find the slant height. Okay, but you have to have your slant height for your formula for the lateral area. And then on number 7, number 6, sorry, I was looking at how many points. On number 6, you only have to find volume only, okay? Because I didn't realize my picture, they didn't label the slant height, and I'm not gonna make you try to figure out how to do it on the pyramid, so you only have to have the one answer on number 6.
Okay.
Okay. So everybody got that?
Yeah.
Any other questions? Now, if you had already turned in the quiz and you, after I talk about this, you're like, uh-oh, I messed up, just resend it to me. Redo it if you want to, send it to me again. I'll take the one where you had fixed them. Okay, so if you went ahead and sent it to me yesterday, but now looking at what I put up here, you're like, I don't think that's what I did. Okay, go back and fix it. That's fine. Okay, if there's anybody that's not here and you know that they need these to have help for the quiz, we can send the picture of it to them, okay? Make sure that they get it. Any other questions for your quiz? Does that kind of help?
Yeah.
Okay.
For number 2,
Uh-huh.
is the height Is the height of the triangle 2.5?
The height of the triangle is 2.5, but that's not the height of the prism.
Okay.
The height of the prism is the distance between the two triangles.
So how do you find that?
It's on the picture. The triangles are separated by the box in the middle, right?
Mm-hmm.
How tall are those boxes in the middle?
6?
No, that's how far it is across. How tall going up and down?
Oh.
You see it? Here's a triangle, here's a triangle. So I'm talking about the height is the distance here between it. It's labeled, how tall is
4. Okay.
it? Okay, so that's your height when you're talking about the height of the prism. Okay.
All right.
Any other questions on quiz? Everybody good now?
Yeah, I'm good.
Time to go eat lunch.
Okay.
All right. Well, don't forget about your quiz, but you can eat lunch first if you want to. I'll see y'all tomorrow.
All right.